Good day, everyone. Welcome to our General Chemistry 1 Class 4, Week 2, Day 1. I'm Ma'am Maria Bernadette Esbiazon, and I will be discussing with you atoms and their isotopes. At the end of the learning episode, you are expected to 1. Demonstrate an understanding of atomic structure, and 2. Recognize common isotopes and their uses. Are you ready? But let's start with our pretest. 1. What isotope is used to locate brain tumors, monitor cardiac, liver, and thyroid activities? A, B, C, or D? Go. 2. This isotope is used for oil well studies and in locating leaks in pipelines. A, B, C, or D? Go. 3. Which of the following emissions travels at the speed of light? A, B, C, or D? Go. 4. Consider the radioactive decay equation given below. What is the most likely identity of X? A, B, C, or D? Go. And 5. What subatomic particles are continuously moving around the nucleus? A, B, C, or D? Go. And the answers are? Did you get them right? Oh, you don't have to be upset if you did not, because you'll be learning about this today. But before we proceed to our lesson, let's have a short recap first. In your junior high school science, you learned about the atom. Can you still recall some of the concepts related to it? 1. Blank, proposed by John Dalton, can be used to explain the laws of chemical change. This theory is based on the following set of postulates. A. Elements are made up of very small particles known as blank. B. All the atoms of an element are identical in mass and size and are different from the atoms of another element. Dalton used the different shapes or figures to represent different elements. C. Blank are composed of atoms of more than one element, combined in definite ratios with whole number values. D. During a blank, atoms combine, separate, or rearrange. No atoms are created and no atoms disappear. 2. Laws of chemical changes were inferred from several experiments conducted during the 18th century using a balance for the measurements. It includes A. Blank, which states that in a chemical reaction, no change in mass takes place. The total mass of the product is equal to the total mass of the reactant. B. Law of definite proportion, which states that a compound always contains the same constituent elements in a fixed or definite proportion by mass. C. Blank, which states that if two elements can combine to form more than one compound, the masses of one element that will combine with a fixed mass of the other element are in a ratio of small whole numbers. 3. The blank is a tabular display of the chemical elements, which are arranged by atomic number, electron configuration, and groups atoms with similar properties in the same vertical column. 4. A blank is an aggregate chemical union of two or more atoms in a definite arrangement held together by a covalent bond. And the answers are? It's nice to know that you can still remember the lesson about atomic theories. Are you ready for our lesson now? Let's begin. Have you ever wondered how small is the coronavirus, SARS-CoV-2, responsible for the COVID-19 pandemic the whole world is experiencing now? What do you think could be smaller than this virus? Did you know that a molecule is even smaller than the coronavirus, and an atom is even much smaller? Studies show that the size of the severe acute respiratory syndrome, coronavirus 2, SARS-CoV-2, ranges from 0.1 to 0.3 micrometer or micron, or approximately 10 to the negative 7 meter. It is relatively bigger than the water molecule at 10 to the negative 10 meter, and a lot bigger than the helium atom, which is only 1 femtometer or 10 to the negative 15 meter. The atom was believed to be the smallest particle comprising substances during the time of John Dalton. However, before the end of the 19th century, experiments provided proof of the existence of smaller particles within the atom. Do you want to know what are those particles? During the early 20th century, scientists discovered that atoms can be divided into more basic particles. Their findings made it clear that atoms contain a central portion called the nucleus. Inside the nucleus are the subatomic particles known as protons and neutrons. Protons and neutrons are often called nucleons. Protons P+ are positively charged, and neutrons N0 are neutral. Whirling about the nucleus are particles